of rational functions, we need to figure out where the denominator is 0. So what we're going to do for each of these problems, when we're trying to find the domain, is set the denominator, in this case 5x squared, equal to 0. When we do this, if we divide both sides by 5, we get x squared equals 0. And if we solve this by taking the square root of both sides, square root of x squared is x, the square root of 0 is still 0. So what this means is that my domain is the set of all real numbers where x cannot equal 0. So if I were to have a graph of some kind, it means that my graph doesn't touch x equals 0 at all. And since this is a rational function, it would look something along this line where it's not crossing that 0 at all. So that's what we're trying to find here. Now if we get something that looks like this, it's the same setup. We just look for where the denominator equals 0. So t squared plus t equals 0. This time I need to factor. If I pull out the greatest common factor of t, I'm left with t plus 1 equals 0. So then I set each of those factors equal to 0. T equals 0 and t plus 1 equals 0. So here I get answers of t equals 0 and t equals negative 1. So my domain is again the set of all real numbers except t cannot equal either 0 or negative 1. It's that easy. That's it. That's all we're looking for. Now if I'm trying to find zeros of a rational function, I'm looking for where the numerator is 0. But I want to make sure that anything I find in the numerator as a 0 is also not in our domain, so I want to simplify each of my rational functions first. If I simplify the rational function first, here I want to factor the numerator of x squared minus x minus 6, and I get a numerator of x plus 2 and x minus 3 all over x plus 1. Nothing cancels out, so I take my numerator x plus 2 and x minus 3 and set it equal to 0. Set each of those equal to 0, we get x plus 2 equals 0 and x minus 3 equals 0. Solving those, x equals negative 2 and x equals 3. So here, what's actually happening on the graph, if we looked at a quick graph, is I'm crossing the x-axis at negative 2, and I'm also crossing the x-axis at positive 3, so it would look something along those lines. Finally, one more time, let's go back to this h of t function. So we're going to factor the top and factor the bottom and see if anything cancels out. In this case, when we factor the numerator and factor the denominator, we get t minus 2 times t plus 1 in the numerator. We get t times t plus 1 in the denominator. Now notice, if we hadn't have tried to simplify this first, we would have gotten this t plus 1 as part of the zeros equation. But since it's also part of the domain issues, we can simplify it by crossing them out. And now we're looking at t minus 2 over t. Set that numerator equal to 0, t minus 2 equals 0, t equals 2. So my 0 for this function is t equals 2.